In chapter 4, we focus on scatter plots, which are graphs that use both an x and a y axis to compare two different variables or two different distributions at the same time, with the goal of being able to determine, well, does one variable influence the other in some meaningful fashion? In chapter 5, we're going to be doing linear regression, which is a process of trying to see how closely these variables are related to one another. And it's always very much a cause and effect battle to see, well, what causes, does this variable cause the other one to change? But the first two terms for this chapter would be explanatory and response variables. Basically, we refer to a response variable as a quantity that is directly affected by something else. It's like its behavior is due to the behavior of other variables within the system. It's not necessarily that something that will be varying on its own, though it could very well be in certain situations. Oops, I'm writing in the wrong spot. Let me move my tablet. Okay, there we go. And yeah, an explanatory variable is something that could be the explain the change in behavior of other variables. Another term this is used for in algebra would be dependent and independent variables. An independent variable is one that we choose to vary as we wish, and dependent variable is one that is changed by the independent variable. So it's basically a synonym. And in linear equations, y equal mx plus b, which is something that we're going to be reviewing and talking more about when we get into regression. Usually x is what's called the independent variable and y is the dependent variable, because x is thought to be the cause of the change and y is kind of affected by that. Where mathematically speaking, it doesn't really matter which one is which, because they're all just variables at the end of the day, but that's kind of the key. So let's look at an example, returning to the similar example from last week's lecture. Amanda, where we studied Amanda's quiz score, we looked at like her mean, her median, her standard deviation of her 7 quizzes, where she scored 100, 92, 54, 91, 83, 99, and 90. And let's add another variable to this. Let's say we know how long she spent studying for each quiz, which is given to us in this table over here. So for her 100% quiz, she spent 3.5 hours studying. For her 92, she spent 4 hours studying, and so forth. And our goal in this, in these couple chapters is to see, well, is there some sort of correlation between how much time she spent studying and how well she did on her quiz, which obviously we would expect there to be some form of correlation at the end of the day. But one thing that is very important with scatter plots is determining which is the explanatory variable and which is the response variable. And another way of saying this is which one's going to go on the x-axis and which one's going to go on the y-axis. And what you want to ask yourself is, which variable do you think is to blame for the other one happening? And so when it comes time to doing well on a quiz, you would expect this study time to be influential on how well she did on her score. It's kind of like you study first, your quiz score is determined by that action. It's not usually thought of the other way around, where you take your quiz and then you correlate it to your time spent studying. Where at the end of the day, it doesn't really matter, but it's more of the common way of presenting information. X is like cause and effect. X is cause, Y is effect. So I would say that the explanatory variable here would be the time spent studying. And again, that means I'm going to choose to put that on my x-axis, and the response variable would be her quiz scores from there. And even though the table, usually when we write data, it's approached as x comma y, here we see the x is on the right and the y is on the left. So we would have to usually I would flip the data and write it the other way in most cases, but it's not presented in that way. But just to mention, it's not always going to be presented as x comma y. You have to think of that. You want to think about it first. And number 3 on our packet says to create a scatter plot of the data. And again, we want to make sure that our explanatory variable is on the x-axis. So this is the time spent studying. Oops, that S didn't come out so well. And then the y-axis will be her resulting quiz score. So to create a scatter plot, we always are graphing it like an ordered pair, like a point where each data point is considered to be related to each other, and the dot at that coordinate location represents the cause and effect sort of pairing. And also, one thing I want to talk about later is causation. Correlation and causation are not synonyms, and when I talk about cause and effect, I don't mean that when we're analyzing this stuff that we know there's a causal link between the two data points. So I'm when I say cause and effect, there's never proof of that. Anyways, but she spent 3.5 hours studying and she got 100. So that would be our first data point. So we want to go to the right to 3.5 and up to 100 to find that point, and we're just gonna place a coordinate on that location. And that, again, that's what that data point means on a scatter plot, is the relationship between those two things, because they're connected. And then she spent 4 hours studying and she got a 92. So that would be right 4 up 92. Sometimes you might not be able to put it perfectly on point, but always do your best. 92 would be 2/5 of the way from 90 to 95. She spent 0 hours studying when she got a 54. She spent 3 hours studying when she got a 91. She spent 2 hours studying when she got an 83. 4.5 hours studying for her 99. And 4 hours studying for her 90. Which would be right about there as well. And there we have a scatter plot of the data. And one of the things we could look at is does there seem to be some sort of underlying pattern on the graph in terms of correlation? We talked a little bit about correlation, the R value, and remember that when we're calculating correlation, it's going to be a quantitative value which will tell us does this data follow a general linear trend. In this data, if I look at it, eyeballing it, it sort of looks like it might be linear, but in the next 2 chapters, we're going to talk about how do you actually calculate a value for the correlation. Remember, the correlation must fall between -1 and 1. And the closer it is to 1, the better it is. The closer it is to 0, the worse the correlation is. And that's what we're going to be working towards in the next couple of videos.